Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shen, coming to you live from Summit Academy. In this video, working on unit number 5 still, talk about lesson 12. And we're going to be working with these 3D solids still, talking about volume, talking about how these shapes work out. So in the first part, it says, what shapes are the faces of each type of object shown here? So for example, a cube has all squares, which is why each of those side lengths on a cube is the same. So for that first one, so let me move this down a little bit. That first one, let's say for A, so for A, we're going to say it's going to be rectangles, since it's a rectangular prism. Then we're going to say for B, since it's a cone, we're going to say it's a circle, and a curved surface. Again, and that's talking about that, that outside amount that has not a rectangle, because it would be that's part of the cylinder, and that's the main difference between the cylinder and the cone, is that the cone comes to a point. And so for our next one, we could say for the cylinder, we're going to say for C, our cylinder, it has two circles, top and the bottom, and it has that curved surface again. And then lastly, for the part D, the sphere, that's just going to be one curved surface. So one curved surface. So just saying, as if you were to flatten them out or, take them apart, what would it look like, as a 2D shape? So each of these, again, are going from 3D to 2D. How we can kind of picture, see what those nets look like. And then this second part, it says which face could be referred to as a base of the object. So we're going to say for the rectangles, we're going to say it's going to be any face. So we're going to say for that part A, we're going to say any face is the base. Any face is the base. Then for the next part, for our cone, we're going to say that circular face is the base. So circular face is the base. Then we have for that cylinder, part C, is going to be either of the circular faces is the base. So we're going to say either circular face is the base, because you can stand that can on either side. It could be upside down, but it still stands there all by itself. And then lastly, what happens when we try to find the face of a circular amount, meaning the sphere? We're going to say that the sphere has no base. That makes sense, because if you were to place a ball all on its own, it's going to roll around because there is no bottom part. All right, so the next part, it says here is a method for quickly sketching a cylinder. So you want to draw two ovals, and then you just want to connect those edges. So similar to what they have in the picture, notice how they have two ovals, and then they have those two side lengths as the height. So which parts of the drawing would be hidden behind the cylinder? So we're going to say those are going to be the dashed lines. And so when you draw it, what you can do is you can say this inside amount, that's going to be where the dashed line is. So practice drawing these out. I'll do 2, and I want you to do 2 on your own. So here is, I'll do 2 examples. So it says practice sketching some cylinders. Sketch a few different sizes, including short, tall, narrow, wide, and sideways. So I definitely want you to do a sideways one. Label the radius R and the height H for each cylinder. So let's try this out. So I'm going to say, all right, let's see if I can try to draw this. I'm going to draw a nice big one so that way it's easy to see. So I draw an oval kind of shape. And the way I do it, I like to draw my two sides first. So something like this. Again, just kind of picture drawing a can. And then what I like to do is I'd like to draw my dashed line now. So I do a little dashed line to show that's the back side of it. Then I have the other part of the oval underneath. That way it kind of gives you that 3D picture. But now the key part is we have to label the radius and the height. So we're going to say, the height is going to be that long side that's not curved. However, our radius, you can do it on the top or you can do it on the bottom, but I'm going to say, hey, from the center of the base to the outside of the circle is going to be our radius. So something like that. Let's try drawing. Let me do a separate one. Let's maybe do a sideways one in blue. So let's do a sideways one. So it's like flip the can on its side. So let's do something like this. Let's say we have a can on its side. Try practicing drawing these out. So I can have cylinder and then its side. You can make sure you label the radius, and then we need to say this that the straight side, the non-curved side, is going to be the height. So even though it's lying on its side, we can still label it like that. So now pause for your turn and draw 2 more cylinders. All right, so now that you have those 2 drawn, we're going to move on to the practice problems. So now we're going to try sketching a cube and labeling its side length as 4 centimeters. And it says this will be cube A. So what I can do, let's draw it. Let's do it like right here. The way I like to draw a cube, again, it's not going to be perfect, but that's okay. We're going to say, hey, if we have draw a square, move it down a little bit, draw a square, and then what you can do is you can kind of draw some parallel lines off of that. So just draw a couple parallel lines going from 3 of those sides, make it kind of like a 3D shape, and then you can, from there, connect those sides, and then you have yourself a cube. Again, there's many different ways to kind of approach this. It's not going to be perfect, but that's okay. But what we need to do is we need to label this A, and we're going to say that each of these, so each side length is going to be the same. It's going to be 4 centimeters. So we say this is 4 centimeters, this is 4 centimeters, and this is 4 centimeters. Make sure that's a 4. There we go. So we have our cube labeled A. Now it says to sketch a cube with sides that are twice as long as cube A and label its side lengths. I'm going to label that as cube B. So make sure, since it's twice, we're going to say this is going to be 8 centimeters. So we have to do it a little bit bigger now, and that's okay. So we have to do a little bit larger, move this down, a little bit larger of a cube. I'm going to say, draw those 3 parallel lines, and then connect them down. Something like that, maybe. And we're going to say this is going to be cube B, and our side lengths are going to be 8 centimeters this time, since it is twice the length. And now it says to find the volumes of cube A and cube B. And remember, when you are looking for the volume of cube, so we say the volume of a cube is going to be equal to the length times the width times the height. And so we're going to say for our cube A, so I'm going to write it like this. I'm going to say volume try that again. Volume of cube A is going to be equal to each of those side lengths. So I have 4 times 4 times 4, which is just going to be equal to 64. Now I say centimeters cubed. Make sure that you have the proper units on that volume. Then same idea for our cube B. We're going to say volume of B is going to be equal to 8 times 8 times 8, which is the same as 512 centimeters cubed. So notice that even though we doubled the side length, since it is each side length is doubled, that means that it's going to be almost like we multiplied by another scale factor. So make sure you calculate each of those separately and make sure you find and have the cubic units on both of those volumes. All right, moving on to number 2. It says several glass aquariums of various sizes are for sale at a pet shop. And it says they are all shaped like a rectangular prism. And it says a 15-gallon tank is 24 inches long, 12 inches wide, and 12 inches tall. Match the dimensions of the other tanks to the volume that each can hold. So what I'm going to do is I'm going to say find volume of each and put them in order. Because when we do that, then we can say, well, if I find the volumes that they have, it's going to be inches cubed, but we can say that, hey, we can put those in order from least to greatest because we have 5, 10, 12, and 30. So what I'm going to do is I'm going to say, okay, for tank, let's do different colors here. Let's say for tank A, I do 36 times 18 times 1 for 12, which is going to be 7,776 inches cubed. So there's A. And we say for B, how much do we have for B? Well, we have 16 times 8 times 10, which is going to be 1,280 inches cubed. And then we can do for C. For C, we have 30 times 12 times 12, which is going to be 4,320 inches cubed. And lastly, but certainly not leastly, we have our rectangular prism D, or tank D, I should say, is going to be 20 times 10 times 12. And that's going to be 2,400 inches cubed. So now we can say is, well, let's match these up. So I would say that, well, out of these three, B is going to be the least. So I'd say B goes with 5 gallons. B goes with 5 gallons. I could say B goes with first one, cross it off. Then I could say my next one is going to be D, because that's 2,400, so that's going to be 10 gallons. So that's going to be D. Then my next one from least to greatest is going to be C. So we're going to say C is going to be 20 gallons. And that means A is going to be the largest, which makes sense because it's the most. So we're going to say A is going to be 30 gallons. So again, make sure you can see how you can approach it like that. Again, I use that formula where volume equals length times width times height. Or you could also use the amounts that are given and compare them to what you had for your dimensions. A couple ways to approach that. All right, on the back for number 3, it says 2 paper drink cups are shaped like cones. the small cone can hold 6 ounces of water. Then it says the large cone is 4/3 the height and 4/3 the diameter of the small cone. Which of these could be the amount of water the large cone holds? So make sure you're talking about an amount of water because you're talking about the larger cone, how much it holds. And so right away we're going to say A and D are incorrect. So we're going to say A and D are incorrect since we are looking for amount of water. So it's almost like you're at the water fountain holding one of those cones, you're trying to compare those, and you wouldn't say, since it has centimeters, it's not centimeters cubed, we know it can't be A and D. And then we can also say that, hey, since the small cone is 6 ounces, we're looking for something that is larger, so we're going to say C is incorrect since it is less than the original amount. So it has to be more than 6 ounces, and so we're going to say the only one left, even though we don't have any kind of calculations, we're going to say it's going to be B because it has to be 4/3 of a difference. So we can say another way to approach it is just by eliminating some of these answer choices, so that way you can get a true or false answer. All right, moving on to number 4. It says the graph represents the volume of a cylinder with a height equal to its radius. And it says for part A, if it says the diameter is 2, what is going to be the radius of the circle? Well, that one's real easy because, again, diameter equals 2 times the radius. So that means radius equals diameter divided by 2. So we're going to say the radius is going to be equal to just 1. Then it says express the volume of a cube of a side length S as an equation. So we know that if we have the volume of a cube, it's going to be the side length to the third power. So we're going to say it like this. We're going to say volume equals S to the third power, because we're talking about 3 of those side lengths times each other. Then for part C, it says make a table of the volume of a cube at S equals 0, S equals 1, 2, and 3. So the way you can do it is like this. We can say, all right, let's make a table. I'm going to say that, all right, we have our side length S and our volume V. And so it's going to talk about when S is 0, when S is 1, when S is 2, and when S is 3. So all you have to do is plug this into our equation that we have right here. So 0 cubed is going to be 0, 1 cubed is going to be 1, 2 cubed is going to be 8, and 3 cubed is going to be 27. So each of those, again, notice how I did 0 to the third power, I did 1 to the third power, 2 to the third power, and 3 to the third power. Again, you're not multiplying by 3, you're multiplying that base times itself 3 times. So 0 times 0 times 0, 1 times 1 times 1, 2 times 2 times 2, and 3 times 3 times 3. And it says for the part D, which volume is greater, the volume of the cube when S is 3, or the volume of the cylinder when its diameter is 3. So we already know the volume of the cube because we just found it. So we say the cube. So we say when S equals 3, our volume is going to be 27. Then we say for the cylinder, let's find that out. So cylinder, when diameter, because it's talking about when diameter equals 3, what is our volume? So we're going to say V equals what? Well, let's look at our graph, find where diameter is equal to 3. So we climb up on our graph, find that point on the line, and so we can say this is the point 3, 11. So that means our volume, when the diameter is 3, our volume is going to be 11. And so when we compare those two, we're going to say the cube has a greater volume. All right. And then for number 5, it says select all points that are on a line with a slope of 2 that also contains the point 2, negative 1. So what you can do here is we're going to say, all right, well, we know it's going to be in the form y equals mx plus b. We already have the slope, so we can replace this and say, well, this is going to be y equals 2x plus b. And then what we can do is take our point that it has, because it has to contain this point. So we have, this is going to be our point where x is going to be 2 and y is going to be negative 1. Sorry, y is going to be negative 1. And we plug that into our equation and solve for b. So we say use point and solve for b. So we say, all right, that gives us this. We're going to say, let's have negative 1 is equal to 2 times 2 plus b, because that's what we're solving for. So this is going to be 4. So we have negative 1 equals 4 plus b. And we subtract both sides, again, use those inverse operations to get b by itself. So we said this is negative 5, which is b. So that means our equation is going to be y equals 2x minus 5. So this is going to be our equation that we are going to graph out here in a second. Another way that you could do this is you can make a table. So let's do an orange now. Let's say make a table and count backwards. And what I mean by that is we say our slope is 2. So we're going to say, if we wanted to, we could say slope equals 2, which is 2 over 1, which is the same thing as negative 2 over negative 1. And the reason why I want to count backwards is because if we need to find when x equals 0. So we have our table, and I can start at the bottom of the table because we can say, start here. And we can say, all right, we're starting at the point 2, negative 1. And what we do is we say our change in y, so again, slope is going to be change in y over change in x. And so we say our change in x is going to be negative 1. Our change in y is going to be negative 2 to get our next point. So 2 minus 1 is 1. Negative 1 minus 2 is negative 3. But we need to keep going because we need to find when x equals 0. So we do the same thing again. We go negative 1, negative 2. So this is going to be 0. That's going to be negative 5. And when I say this right here is going to be our y-intercept. So that's just another way to find our equation that we had already. So now that we have our equation, I'm going to graph equation on Desmos, because we need to see which of these points are on that line. Let me pull up our wonderful Desmos calculator. And let me actually write real quick. Let me write up here what our equation is, so that way we have it. So we're saying our equation is going to be y equals 2x minus 5. Okay, so let me switch back over. Okay, you guys can see it. And let's say y equals 2x minus 5. Okay, So here's our line, and now what we do is we say, okay, any points that are on the line are solutions, but we're trying to figure out which of these points that are given are on the line. So we're going to say, is the point 3, 1 on the line? It certainly is, so that one's good. Is the point 1, 1 on it? It is not, so we're going to say that it is not good. What about the point, let's say 1, -3? That one's on there as well. And what about 4, 0? That one's not on the line. And what about the last one, 6, 7? I don't see it on there, but let me just check. Scroll up, and yes, right there it is. So notice how, again, I can see each of those points that are on the line, and so I'm going to say the ones that I want to choose. I'm going to say A, let's try that again. I'm going to say A, C, and E are on the line. However, B and D are not on the line. So again, a couple different ways to do that. You could have also plugged those points in if you didn't want to use the graph, but I like using that graph because it's a little bit cleaner to see. All right. Okay, make sure you can ask questions as they come up. All right, for number 6, it says solve by graphing and write that solution point. Again, that solution point is going to be an ordered pair, X and Y. Again, this one I know you guys can do, so pause for your turn and graph equations on Desmos. Wherever those two lines intersect is where they are equal. All right, and at the very bottom is our exit ticket, already on one page, and that's okay. So it says, here is a box of pasta and a cylindrical container. The two objects are the same height, and the cylinder is just wide enough for the box to fit inside all four vertical edges of the box touching the inside of the cylinder. If the box of pasta fits 8 cups of rice, estimate how many cups of rice will fit in the actual cylinder, and explain or show your reasoning. So try to estimate, again, if this box fits into here, how much is going to be left over, so that way you can fill the rest of the cylinder. Again, be sure to pause, rewind, replay as needed, and as always, super slam that subscribe button.